Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 2 of a unit current electricity. In today's class we are going to discuss about the certain theoretical aspects. So first we are going to discuss about the drift velocity. So let's begin with drift velocity. This is the random motion of an electrons. That means that this is one of the conductor, and as we have discussed in previous class as well, that if conductor is there, it is having a free charge carriers, and when no potential difference is applied, all the electrons or all the free electrons are having a random motion. Random motion, when I mean, it's let's suppose certain electrons are moving in positive x direction, while some other electrons are moving in negative x direction. Some of the electron might going upward, some of the electron might going downward, and something like this. So when I add this totally, that means the sigma q moving in positive x direction and sigma q moving in negative x direction, they are equal, something like this. Look at this, these two electrons are moving in this direction, it's a positive x direction, while these two electrons are moving in this direction. So net flow of charge is 0. So a concept is, if potential difference applied across the conductor, is 0, current flowing through conductor is 0. This is the always case. I hope this is clear. Now what I supposed to do is that I have connected this conductor, this is again the conductor, and I have connected this conductor with a supply. Let's say a supply is of V. Now as you can see that all the electrons or all the free electrons are moving in the same direction. Let's suppose moving in this direction. All the electrons that we are considering, in actual electrons are moving from the negative plate to the positive plate, but what we are considering, what conventional current we are considering, is that current is going from positive terminal of the battery to the negative terminal of the battery. Yes, so this is the direction, and if all the electrons are moving in the same direction, we understood that current or electric current will be there. We don't know how much amount, we don't know what amount of electric current and up to what will be there, but I know that electric current will be there if potential difference is applied. If potential difference is applied across a conductor, this is the case. If I have given potential difference, then there must be an electric current. Is it clear? So let's look at this situation. Let's come to the drift velocity. So this is the situation, this is the conductor, and this conductor has been connected with the battery. This is the positive terminal of the battery, this is the negative terminal of the battery. So electric current, what we assume, is moving in this direction. As electric current is moving in this direction, that we assume, so this is the direction of electric current. As I know this is the positively charged plate, can I assume? Yes, this is positively charged plate, this is negatively charged plate, and I know that the direction of electric field will be positive to negative plate. Yes, so this is direction of electric field, and I know that my electrons are moving in this direction. Look at this, electrons are moving in this direction. It is opposite to the direction of electric field applied. So this is the direction of drift velocity. So what I know is the rate of flow of electrons from left to right at a point is equal to the rate from right to left, so that the net rate of flow of electron at that point is 0 in the absence of electric field. So if PD is 0, I is 0, that we already discussed in previous slides. One more time at here. Yes, so if no electric field is there, that means no potential difference is applied across the plates of a conductor or across a conductor, current would be a 0. Is it clear? Is it clear? Do you understand this? Correct. Next, if an electric field is set up at every point in the conductor when it is connected to a battery, and this field exerts a force on the electrons. As they move, they undergo frequent collision with the atoms or ions of the conductor. Thereby, they acquire a constant speed in a direction opposite to the field, and this velocity is called the it's a drift velocity. Look at this. As I said that electric field is acting on this direction, electrons are moving in this direction, so their motion would be something like that. It's a zigzag motion, so their motion is called as the drift velocity. And one more thing, it is the VD, it's a drift velocity, it is the electric field, so angle between VD and E is always a 180 degree. Please remember this. Yes, that is what we are talking about. So this is velocity is called a drift velocity, which is of the order of 10 to the power minus of 3 meter per second. Thus there is a net flow of charge inside the conductor. A charge would be there and all electrons are moving in the same direction, so there may be a flow of current would be there. Let's have a look. The collision between the electrons and atoms or ions of the conductor are the inelastic, and there is net transfer of energy would be there. There is net transfer of every energy would be there. Now let's suppose one of the electron is here, another is here, another is here, another is here. So let's suppose this electron is moving in this direction and now it is moving in this direction. So this is at this position, it is having a first collision, and it is at this point it is having a second collision. So we consider the time required between this two collision. It's an average time interval between two successive collision is called as the relaxation time. So this is the time where electron has not undergo any collision. Yes. So now what drift velocity I can write? According to me, it's an V is equals to U plus AT. Yes, let's assume that U is 0 because initially everyone was moving in the random direction, and due to this random direction I could not have any net velocity. So this is 0. Now A, how could I write this? If you remember the first unit, F is equals to MA and F is equals to QE. So this is MA is equals to QE. So this A is equals to QE by M. But its motion and force acting both are in opposite directions. So I have written it's a QE by M into T. And this time is the relaxation time. So I have written this. That drift velocity is equals to minus of E into E divided by M into tau. So negative sign indicates that the electron drift opposite to the applied electric field. Remember this one more time. It's a VD is in this direction. If VD is in this direction, then the electric field must be in this direction, and angle between this two, it's in 180 degree. Yes. So let's summarize something, and these are the points that need to be remembered. So point to remember, very important, please remember this. When electrons are drifted in a conductor, they will have net average velocity and zero average acceleration. Yes. In the absence of external electric field, there will be no current in the conductor, that we know. Yes. Is it clear up till now? Is it clear? Let's look at the next term, electric current density. So what is it? What the current density is all about? Current density is defined as the current per unit area taken normal to the current, and it is denoted by J, something like this. Let's suppose this is the cross sectional area, this is the cross sectional area, then current density J will be written as I divided by A. It's a unit, it's an ampere per meter square. Yes, and as you can see this, it is a vector quantity. The magnitude of current density is the amount of charge flowing through unit cross sectional area per second, and it is a vector quantity. Please remember this, it's a vector quantity. Now if E is the magnitude of uniform electric field in the conductor, and the conductor having length L, the thing is supposed to be something like this. that this is the conductor, this is having a length L, and electric field is applied. Then the potential difference V across its end, I know that E is equals to dV by dx. Yes, so this is E is equals to V by L, and this is V is equals to E into L. So how this arrives? V is equals to potential difference across the ends of the conductor is V is equals to E into L. Yes, so what I can write is V equals to E into L, and that is equals to J into rho into L. Yes, so this E, this LL has gone, and this A is equals to J into rho. Yes, so what is this? E is equals to J into rho. Now the above relations for the magnitudes of E and G can indeed be cast in a vector form. If I want to derive this in a vector form, then it's the current density is also directed along E. This is E is equals to J into rho, or what I can write down is this rho. What is it? Yes, this is the resistivity. I hope you have studied it in class 10th. E is equals to J into rho, and inverse of resistivity is conductivity. So I can write like this: E is equals to J divided by conductivity. So I can write like this: J is equals to rho into E. Please remember this: J is equals to rho into E. If I write down this in a vector form, it should be look like this: J should be is equals to rho into E. SI unit ampere per meter square. Dimensional formula I into L to the power minus 2, that we have already written. SI unit. Yes, J is equals to sigma into E. This is the modern Ohm's law that we are going to discuss. Yes, so done. Now I need to derive a relation with I and drift velocity. I need to derive a relation between these two. So let us consider that a conductor is there, and the conductor is having a length L and uniform area of cross section A, and volume of the conductor is V is equals to A into L. Now I have supplied this with a voltage V, and this voltage V has been connected to the ends of the battery. So current is moving in this direction. This is positive terminal and this is negative terminal. So direction of electric field is in positive x direction, and direction of drift velocity is in negative x direction. So this is all I know up till now. Now let us suppose that we are going to derive a relation for I and drift velocity. So this are certain theoretical aspect. I know you might have studied this theoretical aspect in your school classes, but this is very logical, and this is required in our examinations too. So we are going to cover this. So let's look that if n is the number of free electrons per unit volume, that means I define n as the number of free electrons per unit volume. This is what we call as in this is number density. Always any term that has been divided by volume can be represented or can be considered as a number density. So if n is the number density, it's a number of free electrons per unit volume of the conductor, then the total number of free electrons in the conductor is capital N is equals to small n into V, and this volume can be represented as area into length. Now the total, these are only the total number of free electrons. What I need to calculate? I need to calculate the total amount of charge that has been flowing through this conductor. Then I know that this is Q is equals to N into E, and this N can be written as N into AL multiplied by E. Yes, this is Q, total amount of charge that has been passed. Electric field across the conductor E is equals to V by L, and according to this I can write like this: V is equals to E into L as well. Due to this field, the free electrons in the conductor moves with a drift velocity Vd, towards the left side that we have seen in the diagram. And let us suppose we are applying a constant potential difference V across the ends of the conductor using a battery. So if I have done this, then the time taken by the any free electron to cross the conductor, yes, thus it is something like this: speed is equals to distance by time. So time is equals to L divided by Vt. So time taken by the free electrons to cross the conductor, T is equals to L divided by Vd. I know that I is equals to Q by T, and I am replacing this T by L divided by Vd. So this Q, it's a N into A into L into E, and this is L by Vd. So if I solve this, it's will give me a very beautiful relation, that is I is equals to N into E into A into Vd. Yes, one more thing, that if I replace Vd by E into M, E into E divided by M into tau, I can have I is equals to N E square tau by M into A into E. So this is the current. If I want to write down that current density, then I need to write J is equals to I by A. Then this is equals to N into E divided by Vd, as well as this can be written as, so it's an N into E square into tau divided by M into E, and this is the resistivity, it's a rho, and this is E. So J is equals to rho into E. Yes, this is the resistivity that we know. Sorry, this is conductivity, my mistake. It's a conductivity. J is equals to sigma into E. Yes, this is conductivity. J is equals to sigma into V. Yes, current density in terms of the drift velocity. I hope this is clear. Is it clear? Yes. So last, it's in mobility. Mobility of a charge carrier is defined as the average drift velocity of electron per unit electric field strength. So this is mu is equals to drift velocity, it is Vd divided by E. This is the mobility. If I write down the value of an Vd drift velocity, it is E into E divided by M into tau divided by 1 by E. So if I write this, it's E multiplied by tau divided by M. This is mu, mobility. And one very important aspect is that mobility is independent of electric field. Mobility is independent of electric field. Look at this. It depends on the E, which is a constant term. It is a charge of an electron. It depends on the tau. It's a relaxation time. It is a time between successive collision. And it depends on the mass, which is also a constant. So actually this depends on tau only, because what you can do is that you can provide an energy from the external world, so that your time will decrease, your mobility will decrease, and so on. Yes, I hope these things are clear. But it is independent of the electric field. Yes. So this all are the important formula from which questions has been asked. So let me just summarize this. And it's a summary. That first formula, it's a I is equals to N into E into A into Vt. This I would be an electric current. This N, it's a number density. The small n is equals to capital N divided by volume. This A, it's a cross sectional area. Of conductor. this is cross sectional area of a conductor, and Vd, this is drift velocity. Yes, this is the first. Now the second, current density. The current density J is equals to I divided by A. This J is the current density, and A is the area vector. Yes. Now the next, drift velocity, Vd is equals to minus of E into E divided by m into tau. Yes, this tau is the relaxation time. Now you know what relaxation time is all about, so no need to explain one more time. Next, J is equals to sigma into E. Yes, this is conductivity. J is equals to sigma into E. This is the conductivity of a conductor. And last but not the least, it's a mu, which is the drift velocity. Mu is equals to Vd by E. This mu is the mobility. Yes, but this does not depend on the electric field that we have proved and that we have written on the previous slide only. Yes, so these are the certain relations that we have studied up till now in this 22 minutes. Yes, so are you comfortable with this? Are you comfortable with this all questions and all relations? Are you sure? So will you be able to do certain MCQs based on this? Let's have a look. First, a very easy question. What is the SI unit of electric current? Yes, it's an ampere. Done it. Yes, SI unit of electric current, it's an ampere. Next, how many number of electrons pass through a conductor when 1 ampere current passes through it in 1 second? Yes, it's an I is equals to Q by T, and when I put it's a NE by T, the same thing I have done here. So when I calculate the N, it's an I into T by E. Current is 1 ampere, time is 1 ampere, and charge, it's an 1.6 into 10 to the power minus of 19. So this will give me a 6.25 into 10 to the power 18. Please remember this number. When you proved it's a 1 divided by 1.6 into 10 to the power minus 19. This is 6.25 into 10 to the power 18. This will help us at some else also. So please remember this. It's a 1 divided by 1.6 into 10 to the power minus of 19, which will give me a 6.25 into 10 to the power 18. Yes, let's move to the next question. Which of the following is a fundamental quantity? Now, what fundamental quantity is? We understand that all those quantities which are included in SI system, the 7 quantities were there. They are fundamental quantities. They are fundamental quantities. I hope these things are clear. Yes. So what are they? Which are they? It's an electric current. I want to add one thing here. That question is, write name of the all fundamental quantities. Write down the name of the all fundamental quantities. Please do this. Yes, I know we are in 12th class, but we cannot afford to forget concepts or theory of class 11 as well. So this is necessary. Please do it. And let's move to the next question. What the question is all about. Let's have a look. The question says that the drift velocity of an electron in a copper conductor of cross-sectional area, okay, A is given, is this much, 1.5 into 10 to the power minus of 4 meter per second. So A is given, which is 5 into 10 to the power minus of 6 meter square. Velocity is given, which is 1.5 into 10 to the power minus of 4 meter per second. If the current is 10 ampere, that means I is equals to 10 ampere. Find the number of electrons crossing. It's an N is required. So I am having a relation that I is equals to N into E into A into VD. So my N would be equals to I divided by E into A into VD. Yes, I hope these things are clear. I have replaced the value, and if you solve this, it would be an 8 into 10 to the power 28 electrons would be there. Yes, yes. Let's look at the next question. The relation is, what is the relation between drift velocity of electrons and electric current? Drift velocity of electrons and electric current. What I require, it's an I is equals to N into E into A into VD. So I know that VD is equals to I divided by N into E into A. That's it. This is correct answer. Yes. What was your answer? What was your answer? Is it same? Great. So let's have a look to the certain other questions too. Let's begin with certain questions. If J equals to 2I plus 3J cap, it's an ampere per meter square, and area vector of a conductor is 4I cap plus 2J cap plus 3K cap. Find out current flowing through a conductor. So what I know is that J is equals to I divided by A. So according to this, I know that I is equals to J dot A. So I need to perform dot product of these two quantities. So if I perform a dot product of these two quantities, then I can have I is equals to J dot A. Then the J would be equals to 2I cap plus 3J cap dot 4I plus 2J plus 3K. So this is equals to 2I and this is equals to 4I. 2 4s are 8, 3 2s are 6, plus here no K cap, so it would be a 0. It's a 8 plus 6, it's a 14 ampere. That's it. You did it. Yes. Yes. So can it be done? Can it be done by you? Are you sure? Does it? Great. Ready for the next question? Are you ready? Let's have a look. Let's say a graph is given. This is a graph of I versus A. This is a graph of I versus A. And suppose it is something like this. This is 0, this is 4, this is 6, this is 8, this is 10, this is in ampere, this is in meter square. The question is find out current density at area of 2 meter square. This is what they require. Now look at this. I have been provided a graph of electric current versus area. Basically it's an area vector. So I know that J is equals to I by A. J is equals to I by A. So I need to find out slope of the graph. Need to find out the slope of the graph, which will be current density. So how can you do this? It's a J is equals to I by A. It's a dy by dx, or I can say it's a rather delta y by delta x. So delta y by delta x, it's a 10 from here, minus of 0, divide by delta x, it's a 4 from here, minus of 0. So this is 10 by 4, it's a 2.5 ampere per meter square. That's it. You did it. Yes, it's a J is equals to dy by dx, and this is 10 by 4, it's a 2.5 ampere per meter square. So what was your answer? Is it same? Great. Now let's move to the next question. Let's suppose that one of the conductor is given, and this is side A, this is side B. Now what they have been provided is that current through a conductor is same throughout. Now current is same, that they have discussed. Now what they want is that find out drift velocities at A and drift velocity at B. Now while I say drift velocity find out, that means I am interested in this relation only, greater than, less than, or equal to. I hope you understand this symbolic language. Yes, when I say find out, that means I am interested in this only, drift velocity greater than, less than, or and equal to. I need to find out JA greater than, less than, or equal to JB. I am interested in electric field E at A, E at B, greater than, equal to. Next resistivity R at A, it's resistivity, it's a rho at A, rho at B, greater than, less than, and equal to. Yes, I'm interested in this only. So how can I do this? How can it be done? Yes, if you observe this conductor very carefully, you might get that this I is same because the data has been given. So J is equals to I by A. Am I correct? So I is same, that means J is inversely proportional to the area. So at position A, area of the A is a lower and area vector of the B would be an higher. So as this is higher, J would be a lower, that means JB, or current density at B would be less than the current density at A. Yes, do you understand this? That current density at B is less than current density at A. Now one more thing, we were discussing about the resistivity. Resistivity depends on the material. So rho A would be equals to rho B always. It does not depend on the shape of the conductor, it depends on the material. Yes, there are certain other aspects too, but it is a material and temperature. We are going to see this in the next classes. Yes, that resistivity or even the conductivity depends on this parameters only. So material and temperature, that means resistivity at location A and resistivity at location B, that would be the equal. So I have done this. Now it's a turn for the electric field. Now what is the relation? What was the relation? What I know is J is equals to sigma into E. My sigma is constant. Even the conductivity would be a constant. Even the resistivity would be a constant. So if J is higher, E is higher. That means electric field at A would be greater than electric field at B. Yes, so even this task has been done. Even this is done. Only the term that remains is the drift velocity. How could I do this? Any idea? So what I can do with the drift velocity is that I know that I is equals to N into E into A into Vt. My I is the constant, N again constant, E is the constant. So what I know, it's a Vd, it's an inversely proportional to the A. So cross-sectional area at B is higher. At AB is cross-sectional area at B is higher as compared to the cross-sectional area at A. So as cross-sectional area is higher, drift velocity would be lower. So Vd at B would be less than Vd at A. And that's it. You did it. Great job. Well done. Yes. Do you understand this? Completely? Yes. Any issue regarding this? Is there anything? No? Okay then. Great work. So let's wind it up this session at here only. Yes, this is the theoretical aspect. But the questions has been asked previously as well as there are very high chances that questions from any one of the sections can be asked. So please revise this, learn this formula, revise this formula, and please make a practice of this kind of questions. Yes, thank you, have a good day, take care.